In this example, we are required to calculate the current through each resistance in the given circuit shown in figure. Here we can solve it either by using KVL or KCL. Let's first solve it by using KVL. Then we'll discuss the alternative solution also. Here in this situation, for application of KVL, let's consider in the two loops the current flowing are I1 and I2. I1 and I2 are considered as the current in the loops. And say the loops are named as A, B, C, D, E, F, just like the case we have discussed in the previous section. Now in this situation, using Kirchhoff's voltage law in loop A, B, C, D, A, here we start from terminal A, then if we move along the current, there will be a gain of potential, that is plus 6, it will be minus 5 I1, then it will be minus 4 I1 minus I2, minus 10 is equal to 0. Now in this situation, if we simplify the equation here, you can see the equation will be 4 I2 minus 9 I1 is equals to 4. This is our equation 1. And if we use KVL in loop, in the second loop, if we use the KVL starting from point D, we can write D, C, E, F, D. From here, if we are starting, you can see if you move along the direction of current I2 in this case, there will be first a gain of potential plus 10, then it will be minus 4 I2 minus I1, then it will be minus 10 I2, then it will be a potential drop of 8 volt due to the battery, so this will be minus 8 is equal to 0. Now if we simplify this equation here, you can see this will be 14 I2 minus 4 I1 is equals to 2. Now we can further simplify it, it will be 7 I2 minus 2 I1 is equals to 1. Now save this equation 2, then this 1 and 2 we can solve. To calculate the value of I2, we can calculate the value of I1 from this equation and substitute here. Here you can see the value of I1 we are getting is 4 I2 minus 4 by 9, and if this I1 we substitute over here, you can see this will be 7 I2 minus twice of I1 we substitute as 4 I2 minus 4 by 9 is equals to 1. If we just simplify this expression, you can see on simplifying it will be 9 to 7 63 minus 8 will be 55. And in this situation, you can see the result we are getting will be 55 I2 is equals to 1. And on simplifying the value of I2 we are getting is 1 by 55 ampere. Now in the situation of I2 is 1 by 55 ampere, the value of I1 we can calculate from here, which is 4 by 9 multiplied by I2 minus 1. So this can be written as 1 by 55 minus 1. So the result we are getting is this will be minus 54 by 55. So from this 9 we can cancel it. This will be minus 24 by 55 ampere. That is the value of current I1. That means the value of current I1 here we are getting it negative. That means actually the current I1 is flowing in anti-clockwise manner. We have taken it clockwise and the result coming out is negative. So we can easily get the values of current in 5 ohm resistance. Here in 5 ohm resistance only I1 current is flowing. It is from right to left, so that will be 24 by 55 ampere. If we calculate the current in 10 ohm resistance, this will only be I2 and the value of I2 here is 1 by 55 ampere. And the current in 4 ohm resistance, it is actually I1 minus I2. So I1 is in opposite direction, so these two will be actually added up. So that will be 24 by 55 plus 1 by 55, which is 25 by 55. This can be written as 5 by 11 ampere. So these are the answers to this problem. Let us study the alternative method to solve the same problem by using Kirchhoff's current law. On the previous sheet, we have solved the problem by using Kirchhoff's voltage law or loop rule. In this situation, by using Kirchhoff's current law, we need to first distribute the potentials. And in the given situation, let us consider the potential at the bottom junction is 0. Here we assume it to be 0. And in this situation, the potential at this terminal will be 10 volts. The potential at this terminal will be 8 volt because with this battery there will be 8 volt rise in potential, here 10 volt rise in potential, and here 6 volt rise in potential. The potential here will be 6 volt. And at this junction we are not aware about the potential, so we take this potential to be X. Now at junction X, where the potential is X, using KCL, we have KCL is basically net sum of all outgoing currents at the junction should be equal to 0. From this junction, if we consider a current flowing outward in this 10 ohm resistance, then this current will be X minus 8 by 10 by using Ohm's law. It is the potential difference by resistance plus the current flowing in 4 ohm resistance and outgoing direction will be X minus 10 by 4 plus the current flowing in outward direction, this 5 ohm resistance will be X minus 6 by 5, that should be equal to 0. We just simplify it here, we can take LCM to be equals to 20 and on simplifying the values, this will be 2x minus 16 plus 5x minus 50 plus 4x minus 24, this should be equal to 0. Further on simplifying it as 5 plus 4, 9 plus 2, 11, x is equals to, in this situation it will be 40 plus 15, 90, then the value of x we are getting is 90 by 11 volt. That is the potential of the junction where we have taken an unknown potential x. It is equals to 90 by 11 volt we have calculated by using KCL. Now directly we can calculate the current in individual resistances, like current in 5 ohm resistance we can write as X minus 6 by 5. So value of X is 90 by 11, this is 90 by 11 minus 6 by 5. If we solve it, the final result we are getting is 24 by 55 ampere. Current in 10 ohm resistance here will be X minus 8 by 10. So this is 90 by 11 minus 8 by 10. So this you can see it is 2 by 110, which is 1 by 55 ampere. And current in 4 ohm resistance here will be, here you can get it X minus 10 by 4. The potential difference by resistance, we are simply using Ohm's law, nothing else. So it will be 90 by 11 minus 10 by 4. So that will be 20 by 44, that can be written as, again, this will be negative of 5 by 11 ampere, but negative implies actually the current is going up. It is only just giving us the idea about directions. As far as magnitudes are concerned, these are the answers to the problem which are same, which we have calculated by using KVL.